thing we're going to do is we're just going to solve some equations that have something in them that's squared. But notice that x is completely contained in the squared in each of these equations, which means I don't have to factor it or anything. I can still get the x squared alone. Once the x squared is alone, what am I going to do to solve the equation? So once I get like x squared equals a number, how are you going to finish solving that equation? The square root. Okay, so the point of doing these beginning exercises is to point out to you guys, if you have all of your variables contained inside of something that's squared, get that thing alone and then use the square root to get rid of the squaring. Okay? So in the first problem, we would subtract 5 from each side, which would give us 3x squared equals 15. And then if we divide both sides by 3, we would get x squared equals 5. And just like you guys said, at this point, we would want to take the square root. And what are my solutions? Good. X could be both positive or negative rad 5. So remember, when we square root both sides of the equation, we include both positive and negative. Because if I walked in the room today and said, I'm thinking of a number, when you square it, you get 4. What number am I thinking of? What's the first thing that pops into your head? 2, and that's correct. 2 squared is 4, so that's a possibility. But what's another number that when you square it, you get 4? Negative 2. So the issue is when someone writes x squared equals 5, you don't know if the x was rad 5 or negative rad 5 before they squared it and ended up with 5, so you need to include both possibilities. Okay? So there's 2 solutions to this problem here. All right, so same idea in part B. We would add 3 to both sides. We would divide both sides by 8. This is the same problem we just talked about. Something squared is equal to 4. So algebraically what we're doing is taking the square root. But again, that could be positive or negative 2. Right, so just a little bit of review of how to solve something where there's a perfect square. Because today's goal is to complete the square. When we complete the square, we're going to put something extra into the equation to create a perfect square. Why would we want to create a perfect square? Because if we create a perfect square, we can use this method of solving to then figure out what the value of the variable is, right? If we make this part of it, we can do all this other solving stuff like we know once we have the perfect square in there, okay? All right. I'm going to give you guys a couple minutes in your group to see if you can figure out anything about this. So the total area of 3 congruent circles is 500 centimeters squared. Find the approximate radius of each circle. All right. What information do you have to know? Good. How to find the area of a circle, and how do we do that? Pi r squared. Okay, so the area of a circle is pi r squared. Are the area of these 3 circles going to be the same or different? The same. What word up there tells you that the 3 circles are going to have the same area? They're congruent. So same size, same shape. So what's the total area going to be of all 3 circles? 500. Okay. What's it going to be as in terms of pi r squared? 3 of those, right? So 3 of these should equal 500. How am I going to solve this? See?
Times 3 by pi.
Okay, so you could times 3 by pi. I'm not going to get out my calculator yet till the end. So is it okay with you if I just pretend like that's a package right now, 3 pi? Yeah. And the reason I'll just point this out is because sometimes you'll be able to do the calculation, and then other times they'll ask you to leave your answer in terms of pi. Okay, and the last thing I'll have to do is square root. Okay, so go ahead on your calculator and figure out what 500 divided by 3 pi is, and then the square root. You do have to be a little bit careful about how you enter this. If you do what Zeke said and you do what 3 pi is first, and get a number for that, and then do 500 divided by that number, you'll be fine. if you enter this in your calculator as 500 divided by 3 pi, your calculator may do 500 divided by 3 and then multiply it by pi. So if you're uncertain, you should always just put in a little extra set of parentheses so that it understands where that is in the fraction. Okay? Or put it in a fraction. But knowing how to use the calculator is very important. 100. All right, so this would be 81 over 4 because we're taking the middle term, dividing it by 2, and squaring it. The reason I'm making him give it to me in terms of a fraction, because if later on I need to take the square root of this and I'm not working with a calculator, when you guys look at something that says like 20.25, my guess is not a lot of you are really familiar with taking the square root of that. But if you took the square root of 81 over 4, what would you get? 9 over 2, okay? We know a little bit more about working with fractions, and we're not always going to have a calculator at our disposal, so I'm always going to do them in fraction form. I'm not saying you can't do them in decimal form, but I'm saying that there's going to be a place where you're not allowed to use a calculator and you need to be able to do this. So in my personal opinion, I believe that it's easier for me to deal with fractions because I can at least manipulate those radicals. If the decimals get really complicated, then I don't know the square roots of them, okay? All right, now what about part C? It's a little bit tricky. So it'd be 9. All right, so let's look at this. First of all, what's a little bit tricky about part C? There's a coefficient in front of the r. So can we just take negative 18, divide it by 2, and square it? No. What did we have to do when there was a coefficient there to make this fit this pattern? Yeah, divide the whole thing by 2 or factor the 2 out. So the 2 would come out. This would leave r squared minus 18r. And I'm just going to leave a blank space right there because we didn't know what number was there before. So if I factor, sorry, it should be 9. If I factor a 2 out of it, then it's not really going to matter. Okay? All right, now, ignoring that we factored out a 2 for a minute and just concentrating on the polynomial we have here, what number would go in the C spot there to complete the square? Stephanie? So 81 over 4, so we take the negative 9, divide it by 2, and square it, which would be 81 over 4. Now, is 81 over 4 the same number that we want to go put up in that C spot? No, because up there, C represents after the 2 has already been multiplied back through, right? So just multiply the 2 back through and see what number would be there. So if we do that, so we would have our 2r squared minus 18r. That shouldn't be surprising. That's what we had before. And then what would be that constant of C that was sitting here at the end? Good. 81 over 2, because that 4 and that 2, okay, would cancel out. So that's the number that belongs in that spot. But again, I couldn't figure out that number until I removed the coefficient and looked at it without that there. Because this simple pattern we found only exists when you have a lead term of x squared, not with something else x squared. Okay? All right. So how are we going to use this? We're going to use it to solve quadratics. Now, this tends to be people's least favorite or kind of least used method of solving quadratics. So I'll say in your homework you're going to have problems that tell you to solve it by completing the square. Practice it. Okay? Solve it by completing the square. If on the test I give you a quadratic, and I will, but I don't dictate how you solve it. I'll just say solve the quadratic equation. I might ask you why you chose to solve it the way that you did. Okay? Why would you choose to factor it? Why would you choose to use the quadratic formula? Something like that. Why would you choose to complete the square? Because there are some times when one way is more efficient than another. Okay? Or you just got stuck at a certain point and you're like, I just rely on the quadratic formula when I'm this frustrated. And then that's a valid reason at that point. Okay? But this skill is going to be used for more than just solving quadratics. So I'm pointing that out because a lot of students will tell me, like, I'm not going to learn completing the square because I know quadratic formula and I know factoring and I know I can solve everything you give me doing that. That's fine. There's going to be another section called conic sections where we are going to have to complete the square multiple times within an equation just to get the equation into a form that's useful to us. So this skill is not something that's just going to stop here. We're going to use it again. And we're going to use it here not just to solve stuff, but also to rewrite stuff. So it's really going to benefit you to latch on to the idea here and not have to relearn it again later, okay? All right, so we're going to solve by completing the square so we can get used to completing the square. So first you would look at the equation in part A. Is x squared plus 2x minus 120 a perfect square? No. Okay. So what we're going to do is we're going to adjust it. We're going to make it a perfect square, but we are going to follow all mathematical laws and rules for solving equations. So the first thing I'm going to do is I'm going to move the 120 to the other side of the equation. So I'm going to add 120 to both sides. The reason that I'm doing that is because the reason this can't be a perfect square is because 120 doesn't fit the pattern that I'm supposed to have. So by moving 120 over, what I'm doing is I'm creating space for me to fill in my own constant that I want to be there to make it a perfect square. Okay, so these are like the problems we just did. What number would I pick to be the constant right here to make this a perfect square? Any ideas? 2? So if we take 2, divide it by 2, and then square it, what are we going to get? 1. So the number here should be 1. But now I've done something major. I just did break a math law unless I follow this up with something else. I took an equation that I'm supposed to solve, and I added 1 on one side of the equation. So I have currently changed the problem to benefit me, but have I done it in a way that's fair? Are you allowed to just plus 1 on one side of the equation whenever you want? No. Okay? But if I want to plus 1 on that left side of the equation, what can I do that will make it mathematically okay and I can still keep my plus 1 right here on this left side? Good. Add 1 to the other side. Then it's fair, right? Are you allowed to add whatever you want to both sides of an equation? Absolutely. So I just need to make sure that I put equal amounts on both sides of the equation. Okay? Because now I've changed the way it looks, but I haven't really changed what the equation was worth at the beginning. Now remember, our whole purpose in doing this is to make a perfect square. So your next step after making a perfect square should always be that it factors as a perfect square. Otherwise, what was the use in doing that? Right? So what does x squared plus 2x plus 1 factor as? Should be a perfect square. What should be the first number in the binomial so that when you square it, you get x squared? And what should be the last number so when you square it, you get 1? Everything here is plus, so it's good. Okay. And then on the right side, 120 plus 1 is just 121. And now I have a problem that I can set up by doing those simple square roots like we were doing at the beginning. So I'm going to go ahead and take the square root of both sides. So I would get x plus 1 equals plus or minus 11. And again, I would solve 2 simpler problems. X plus 1 equals 11, or x plus 1 equals negative 11, giving me that x could be 10, or x could be negative 12. Okay. So we're going to use completing the square for 2 reasons. Reason number 1, to help us solve quadratics. Even if you're like, I don't like this method, just try to get used to it because we're going to also use it to help us rewrite stuff, and that's where it's going to become really useful for us later. All right, for part B, is it a perfect square? No. Okay? So I'm going to work on making it a perfect square. Okay? So the first thing I'm going to do is I'm going to move the constant that I don't want to the other side of the equation to try and focus on getting my perfect square on one side. So 2x squared minus 7x, and I'm going to subtract 12 from both sides. What kind of work am I going to have to do on the left side to add the right amount to make it a perfect square? factor out the 2. Okay, first thing that needs to happen is I'm going to factor out the 2. Now, I don't have to factor it out from the other side, okay, because I can just do this work here. But so what I'm really looking for over here, I'm going to rewrite this with the 2 factored out. Now, the first term is x squared. What's the second term going to be when I factor out a 2? 7 over 2, right? So it's not pretty. It's okay. I'll deal with it, and I'll deal with it in fraction form, and it's going to be okay. Promise. All right, now within the parentheses, I can follow the pattern to try and figure out what I should add in there to be the constant that makes it a perfect square. So what do we do to complete this square? Divide b by 2 and then square it. So we're basically taking b, which was already a fraction. Then we're going to divide that fraction by 2 and then square it. So those of you that hate fractions, you need to get over it. Okay? So negative 7 over 2 is being divided by 2, and then we're squaring that answer. Okay? So this is like negative 7 over 2 being multiplied by 1/2, and then being squared. So this is negative 7 over 4 being squared, which is 49 over 16. Okay? Oops, sorry. 49 over 16 is really ugly. There it is. Okay. So is everybody okay with how I did that? Same process. I didn't change the process. I had to do fraction math. Worst case scenario, do what I did. Write out your fraction math, okay? Negative 7 over 2 divided by 2 from like 4th, 5th grade. Negative 7 over 2 divided by 2 is the same thing as negative 7 over 2 times 1/2. Yeah, you might think this is a pain in the butt, but if it's the difference between having the right number versus the wrong number, it's going to be worth taking the extra 30 seconds and write this out on your paper, okay? All right, now remember, my whole purpose of completing the square means that now this polynomial right here should factor as a perfect square. So this should now all go here. Oh, I totally forgot something, though. Who knows what I forgot? See? Yeah, and actually, it's not 49 over 16 that I have to add to the other side, so this gets a little bit tricky. I wrote down the number 49 over 16. But what's happening to 49 over 16 when I write it in this set of parentheses? It's getting multiplied by 2. So it looks like 49 over 16, but it's really worth a different amount, right? How much is it worth? What is 49 over 16 when it's multiplied by 2? So 2 goes into 16. It'll leave an 8 in the denominator. So it's really worth 49 over 8. Once it's multiplied out, that's how much I need to add to the other side. So no autopilot. No, like I wrote this, so I write it on the other side. You got to think about how much you really added to the left side and make sure you're adding an equal quantity to the right side. Okay. All right, now, where I was before, I almost forgot that step, is I was trying to factor our polynomial. Okay. And then once you have this, again, it shouldn't be that hard to factor. Yeah, so this is an ugly number, 49 over 16. What do you square to get 49 over 16? 7 over 4. This one's negative, which means this should be minus sign if I wanted to multiply out and be like that. Okay? Yeah, I get over here you're like freaked out because you have some fractions, whatever. We'll just make a common denominator and add them together. It's going to be fine. So if I want a denominator of 8, 12 times 8 is 96. So negative 96 plus 49. Oh, I wrote 8, but I meant 6. So 96 minus 49 is what, smart people? 47? Yeah? Okay. Getting there. All right, so now what am I going to have to do to finish solving this equation? I'm done completing the square. Now I just have to be able to solve. What needs to happen? Denisa? Yeah, I want to divide both sides by 2. And those of you that are going to freak out when you come over here and you have a fraction divided by 2, dividing a fraction by 2 is the same thing as doing what? Dividing by 2 is the same as multiplying 1/2. So if you don't like to write it like this, then don't. You can just write it like this. And this is actually like a gift right here. You guys think this is bad, but it's really not that bad. Okay. Except for the negative 47, but we'll talk about that later. So at this point, I want to square root both sides. And this actually works out not that badly. So I have x minus 7 over 4 equals plus or minus. Now the numerator is ugly. We'll talk a little bit about that. The square root of negative 47. But in the denominator, what's the square root of 16? 4. Oftentimes you'll find that if you deal with these in fraction form, as I suggested earlier, that things will work out just fine as far as being able to do the operations. Yes, Soraya? Where? Here? Over here? No, so this is plus. So I added something to this side. I need to add the same amount to that side. Is that okay? If I did them on the same side, if I add 5 on the same side and subtract 5 on the same side, that would be okay too. But if I put them on separate sides, exact same amount. All right, so I have two equations here. I'm going to finish it right up here so you guys can see it. I have x minus 7 over 4 equals the square root of negative 47, and I know some of you are freaking out about that. It's okay. And then I have x minus 7 over 4 equals negative square root of negative 47 over 4. Okay? So in both cases, to finish solving these problems, I just have to add 7 over 4 to each side. Okay? So they're going to look a little funny. Oh, forgot my negative. Yeah, it's in there. Okay? So the way you can write your final answer. You will probably see it written most often. 7 plus or minus. Talk a little bit about the radical. The radical that we can't simplify, so I'll leave there. And a 4 in the denominator. Okay? This is two solutions because of the plus or minus here. Now, who knows what's... So what would we say right now if we had a square root with a negative underneath it? Not 0. No solution, right? No real solution. Okay? What we're going to learn later this week is it does have some type of solution. Okay? A complex number solution, an imaginary solution. But for right now, we would say no real solutions. Okay? Yes? Uh-huh. So remember that I wrote 49 over 16 right here, but that 49 over 16 is getting multiplied by 2. So like let's say I put the number 10 right here. It looks like I added 10 to the side, but really I added 20 to the side because the 10 is getting multiplied by 2. So same thing here. So when I multiply 2 times 49 over 16, the 2 cancels with the 16 to make 8. So that's why 49 over 8 is on the other side. Okay? All right. Last thing we have to know how to do. I know, sorry, there's a lot of stuff with completing the square. That's why I had to do it on a full day when I was here. All right. Is we want to be able to rewrite equations. So we want to rewrite each of these equations in vertex form. What form are they in right now? Standard form. Okay, what does vertex form look like? Stephanie? All right. So why we would have to know completing the square to rewrite some of this stuff in vertex form. Notice what vertex form has in it. It has right here a perfect square. So it has to have that perfect square created in there. Okay? So when you look at the equation x squared plus 10x plus 27, is it a perfect square? No. Okay? So what we want is the part that needs to be part of the perfect square. I'm going to kind of organize my equation. So I would like the x squared and the 10x to be part of something that factors as a perfect square because this perfect square is supposed to contain all of the x's, right? Then anything that's being added to it that's not part of the perfect square, like 27, I'm okay with that happening after the set of parentheses because it's kind of like the plus k value that's out there at the end. right? So I'm going to work on making a perfect square within the parentheses so it factors as something squared. And I know that I might possibly have other stuff beyond the parentheses. Okay, I haven't changed anything yet. I just kind of reorganized stuff the way I'm thinking about it and grouping it together. I want the parentheses to be a perfect square. Okay, I want this part to be able to factor like this. That's how I'm going to get it to look like vertex form, which means I want to add the number here that's going to complete the square. Okay. So what number is that going to be? David. 25. Okay, so the way he got that, he took 10, he divided it by 2, and he squared it. Now, I have a couple of choices here. If I add 25 to the left side of the equation, then I need to add 25 to the right side. But do I really want to put anything on the right side? No. Can anybody tell me a way that I could still kind of even out my equation, but I could keep all the information? Sorry, I was using the wrong lefts and rights because I was facing this way. But so if I don't want anything on the left side, but I want it all on the right side, how could I do that? People? Yeah, Nicole. Good. I could subtract 25, and I've still done something to the equation that looks different, but really in the end, it's worth nothing more than what the equation had in it before. 25 and a minus 25 would cancel each other out, be 0, and we'd be back to what we started. But the reason I did this is so that this could be rewritten as x plus 5 squared, and then my constant would depend on this arithmetic. So a positive 27 minus a 25 would be positive 2, and there would be my equation in vertex form. Okay? So last one, we'll finish just in time. Same idea, but why is part B more difficult? Austin? Okay, so A is 2 and not 1. So like to be perfectly honest with you guys, I know completing your square is not your favorite, but it's actually not that bad sometimes. The sometimes when it's not that bad is this idea. When you have no lead coefficient and this middle number is nice and even, so when you divide it by 2, you don't get a fraction and then you square it. I'm not really giving you a choice. I'm making you deal with the fractions also. But if I was given a choice of how to solve a problem, like I probably wouldn't solve this one using completing the square. But this one I might. Like the numbers really aren't bad, and if you're used to the process, it could go really fast. It might even be faster than the quadratic formula if it was set equal to 0 and you were finishing solving it. Okay? But here we're asking you to rewrite. This is what we're going to be doing a lot of in the future, so we have to get really used to this skill. Okay? So again, we said the difficult things were there's a lead coefficient of 2, so that's a bummer. Also that the number's 7 in the middle. Like, that's not nice and divisible by 2 and going to be nice for squaring, but I can't really do anything about that. So again, the stuff that's going to build my perfect square here and that constant that's not part of my perfect square, kind of push it out a little bit. And then like you guys said, can't really have a coefficient there. So I have to factor 2 out of what's in the parentheses. Does the 10 get divided by 2 when I factor the 2 out? Is the 10 inside the parentheses? No. Then it didn't get 2 taken out of it. So it's just over there as 10 still. Okay. All right, so the numbers are not going to be pretty, but whatever, we're going to deal with them. So I'm going to take 7 over 2. I'm going to divide it by 2, which is the same as multiplying it by 1/2, and then I'm going to square it. So this is the same numbers we dealt with before, so we get 49 over 16. Now again, I just wrote 49 over 16, but what is that really worth since it's being multiplied by 2? 49 over 8. Like, what do I get after I multiply 49 over 16 by 2? 49 over 8. So I could either add 49 over 8 to the other side, or if I want to do all my work on the same side, I could subtract the same amount that I've added to this side. So 49 over 8. Okay. And again, the numbers might be ugly, but it doesn't even matter here. You're not even solving. You're just rewriting. Okay? So all you have to know is what squared makes 49 over 16. 7 over 4. And then you do have to do this fraction arithmetic right here. Okay? I'll put a 1 under my 10. I'll make a common denominator of 8. 80 minus 49 is 31. So there's my equation. I might not like it, okay, but this means my vertex is at negative 7 over 4, comma 31 over 8. That wouldn't have been nice to figure out any other way either, okay? If you had to do negative b over 2a and then plug this in to get this value, that might have been just as difficult. So this can be helpful, and we're going to be rewriting a lot.